Jairam ji ki. The topic is sampling. The objective of this topic is importance of sampling in analysis of food. We will describe different sampling techniques and find ways to draw a representative sample from the lots, prepare sampling plans, and we'll talk about standards and guides on sampling. Let's talk about that. All was the probability and probability sampling. Now we are at random sampling. Now we talk about known probability sampling. Now in case when it is not possible to collect or not desired to have a representative sample, we carry out non probability sample. यहाँ मैं एग्जाम्पल बताता हूँ. जैसे मान लीजिए आपका ग्राउंड नट का लॉट है और ग्राउंड नट में आपको ये चेक करना है कि इसमें अफ्लाटॉक्सिन है कि नहीं, अफ्लाटॉक्सिन कितना है. तो आपको पता है कि अफ्लाटॉक्सिन सारे ग्राउंड नट्स पे नहीं है. या सिमिलरली मान लीजिए आपको फ्रूट जूस है, फ्रूट जूस में आपको कोई कंटेमिनेशन है, तो सारे में कंटेमिनेशन नहीं है. वो हमको ये पता लगाना है कि कंटेमिनेशन कौन से एरिया में है. तो ये कौन पता लगाएगा? ये पता लगाएगा सैंपल कलेक्टर. सो फॉर एग्जांपल rodent contamination in food products. So objective of sampling is not to have a representative sample of the population, but the idea is to have the sample which is actually affected, which is actually contaminated, because that is what is we are going to check. We are not going to check how much is the total rodent contamination in the total lot. No, we have to find out where which portion is affected. As we have already seen, the aflatoxin is not there on all the groundnuts. It will be on certain groundnuts. We have seen that the grapes, pesticide is not there on all the grapes. So in such cases, we carry out, the sample collector will decide, will judge, rather than statistical considerations like we have in the probability sampling. So which sample is to be selected is up to the collector. The type of sampling is done in many ways, but in each case the probability of including any specific portion, कौन सा portion sample करना है, it is not equal, it is not like random sampling, because the investigator, the collector of the sample, he will select कि कौन सा sample लेना है. So it is very important for you to have this in mind, to keep this in mind. Judgment sampling is similar to what we have just said, where the judgmental, it is highly dependent on the person drawing the sample. It is up to his judgment which sample is to be drawn, because we are doing the non-probability sampling. The same thing is convenience sampling. We pick up what is convenient, which is convenient to sample to find about the lot. This again is non-probability sampling depending on our requirement. Restricted sampling, when the entire population is not accessible. जैसे मान लीजिए मटेरियल ट्रक में है और ट्रक में से आपको सैंपल ड्रॉ करना है. सो यू कांट गो टू ऑल द एरियाज, सो देन यू हैव टू मेक श्योर रिस्ट्रिक्ट, यू हैव टू डू द रिस्ट्रिक्टेड सैम्पलिंग. जहाँ जहाँ से आप निकाल सकते हैं सैंपल वो ही लेंगे फ्रॉम द लोडेड ट्रक. सो दैट इज रिस्ट्रिक्टिव सैम्पलिंग. The bulk sampling is from the bulk materials like flour, grains, and there we carry out, we collect the samples from different places, different sacks, store each of them separately in the containers, and we make sure, if necessary, we will make a composite sample, and we make sure they are stored properly, transported properly to the laboratory. Now there are two categories for accepting the sampling. First, you accept the sample by attribute. So classifying the unit of a product as defective or non-defective, counting the number of defects. Remember always that there is no food which is perfect, which will have zero effect. It is next to impossible to have any product with zero effect. So there will be defects, but we have to make sure that defect is not fatal. If it is a fatal defect, then it has to be zero effect sample. So classifying the unit of product as defective or non-defective, or counting the number of defects so that acceptability can be there. So sampling decided based on acceptability of a lot based on whether the sample possesses a certain characteristics. जैसे मान लीजिए हमको क्लोस्ट्रीडियम बोट्यूलिनम चेक करना है, कंटेमिनेशन है कि नहीं है in canned foods. So in attribute sampling, what we do is accept each unit if it has that, if it passes that limit, if it is meeting that, it passes. If the microbial load is more, the sample fails. If number of rejections exceed a predetermined number, then reject the sample. हमने डिसाइड किया कि 5 लॉट हम अलाउ करेंगे. जैसे मान लीजिए out of 50 random samples, if 2 samples are scratched or broken, then inspector will reject it because it is already decided that 2 defects are not acceptable. It has to be less than 2. So if 2 samples are scratched or broken, the inspector will reject the consignment. Accept the lot if the number of rejects is less than the predetermined number. A product sold in lots of 1000 kg, as I have told you, if you have drawn 1000 items, 50 samples and 2 samples are broken, then the whole lot will be rejected. So basically this attribute sampling is binary. Binary means it is very rigid, either pass or fail. So either an attribute is present in the test or not, that is to be checked. There should be never any traces of melamine in milk, for example. So when we say there should be not even traces of melamine, so any melamine found in the milk, the whole lot will be rejected. Any arsenic in waterborne is variable sampling. We know very well, this point I must really emphasize very clearly, that arsenic in water is present, widespread contamination of groundwater with arsenic. Now, can we afford to have attribute sampling for arsenic in water? Certainly not. So in those cases, what we do is, we don't follow the attribute sampling. We follow the variable sampling. And in variable sampling, we quantitatively find out how much quantity of arsenic is allowed in the water, and we do the sampling for that purpose. So that is called sampling by variables. So a certain limit is maximum residue limit is prescribed MRL value, and based on MRL value, beyond which if it goes, then it fails, but if it is within that, then sample will pass. So sampling to estimate quantitatively the amount of substance, as I told you, arsenic in water, but not like melamine in milk. Suppose we have said 0, or some microbes, they are not supposed to be present, then it is not variable sampling, it has to be attribute sampling. So compare the estimate obtained from the sample with an acceptable value. If it is within the limits, then pass the sample. If it is failing that limit, then you fail the sample. So this type of sampling produces data that have a normal distribution. We find out what is the residue level in this, and we normally carry out various kinds of monitoring of products that we export day in, day out. Especially APEDA does this for various kind of products exported. So acceptance sampling differs from the previous types and involves the application of a predetermined plan to decide whether a lot or goods meet defined criteria of acceptance. The risk of accepting bad or rejecting good lots are stated in conjunction with one or more parameters. For example, quality indices of the plan. Statistical plans can be designed to regulate the probabilities of rejecting good lots or accepting bad lots. Remember, rejecting good lots is a vendor risk, accepting a bad lot is a consumer risk, and it has to be kept in mind while carrying out the sampling. Now let us see comparison of the two, attribute plan and variable plan. I have already told you about why do we need variable plan in cases where we can't have, we can't just allow the attribute plan. We can't reject water sample if arsenic is present. But if it is attribute plan we follow, then we must reject the water, no matter how much arsenic is present. That is why we go for MRL values, maximum residue limit allowed, and that is where the difference comes. In the case of variable plan, for example, more effective than attribute plan for the same sample size of increments. LQ is lower. What is LQ? There are two terms, LQ and AQL. AQL is acceptable quality limit, and LQ is level of quality, limit for quality, limit for quality for rejection. So AQL is for acceptance and LQ is for rejection. And lower the value of LQ, the better is the consumer risk taken care of. So the variable plan is for AQL and attribute plan is for LQ. They cannot be used in all cases because to validate the calculation formula, the mathematical law of distribution of inspected variable must necessarily follow or approximately follow a normal law. So that is what we follow, the normal algebraic law while deciding it. Remember, in the attribute plan, it is less effective than variable plan. For a same sample size of n increments, the LQ is higher in the case of attribute plan, but in the variable plan it is otherwise. Let us see the operating characteristics to know about what is the probability of getting a sample accepted with defects. This picture shows about a distribution, and basically probability sampling is based on this kind of distribution information. So on the x-axis is lot fraction defective, on the y-axis is probability of its getting accepted. Now remember, probability of acceptance PA for any level of lot quality versus the quality characteristic. This OC curve enables to evaluate the probability of acceptance. We can interpret the curve in this way. Suppose if the lot quality has 0.093 fraction defective, that means 9.3% defects are there in the product, then the probability of its acceptance is 0.05, that means only 5% cases it will be accepted. If the lot quality is 0.018 fraction, that means 1.8% defects, then its probability of getting accepted is 95%. So in 95% of the cases, the sample will pass, the lot will pass if its defect level is 1.8%. And if defect level is 9.3%, there are only 5% chances that the lot will pass. The same way is an example where n number of samples like 52 and C3 is the defects allowed. Now you see in this case percent defective lot plotted against PA. So defects percent with probability of acceptance, and you see it here that as your defects are low, for example defect is C is 3, so the percentage of sample passing is almost like 88, almost close to about 90 or 90% more the sample will pass. So requirement of good sampling method, let us talk about it after having seen the sampling and probability and non-probability sampling. The first is inspection of the lot before sampling. Use suitable sampling device for drawing the sample. Use of suitable containers to hold the sample. Maintain the integrity of the sample and associated records. This is very, very important. Precautions in preserving the sample. We use some preservatives if necessary. Appropriate storage conditions. Make sure that the sample doesn't get spoiled from the point where you draw the sample, collect the sample, and by the time it reaches the lab. All these factors have to be objectively seen from the regulatory point of view. For a given AQL, I have already told you acceptable quality level. The smaller is the sample size, the smaller is the cost of the sampling. But risk of wrongly accepting a lot increases and it worsens the damage in the trade. So AQL, we have to adopt taking care of this. The causes of error in analysis making the data unreliable. Number one is sampling bias. If you have drawn the sample non-statistically viable convenience, and it may compromise the reliability, and if you follow that and not following standard procedure, you are compromising the reliability. Poor understanding of the population distribution. Without understanding the population distribution, one should not carry out the sampling. Subsequent selection of an inappropriate sampling plan introduces the big error. We have seen it. The sampling plan has almost like 50 to 60% of the error in analysis results due to wrong sampling. Non-statistical factors such as poor sample storage may also result in sample degradation. Store samples in container that protects it from all kinds of heat, light, air, and protect against changes in moisture content. So store sample in airtight box. These are the precautions we have to do. Now let's talk about subsampling. So if the test portion analyzed does not represent the lot or population, in that case, even the best analysis could give misleading information. So distortions introduced at this stage will carry through the path of analysis and adversely affect the results and the conclusions drawn from them. So what do? We prepare a composite laboratory sample. All those samples we collected from different sacks, for example, multiple units. So we prepare a composite sample and examination of individual units. So we have to see the composite sample as well as individual unit. A composite sample is nothing but mixture of individual units, because when collecting the sample, we collected a lot of samples, and if the results indicated that there may be a problem, it will be necessary to go back and analyze individual samples. So what we are basically saying, that we do the analysis in the lab with the composite sample, but if composite sample is not giving us the desired results, then we go back and see individual sample and carry out the analysis on individual sample to find out where the problem lies. Sample preparation is very, very important. How you are preparing the sample, whether you are losing the volatile organic compounds during the sample. We are supposed to do the reducing the size by coning and quartering, rolling and quartering, splitters. For sample disintegration, for example, we use mills, grinders, screening. So during screening, we must make sure that we don't lose the fine particles while screening and collecting the sample. So the light sensitive samples, we store them in containers which do not let the dark opaque glass containers, or containers which do not let the light enter there. Store oxygen sensitive samples under nitrogen condition. Preservatives, we have already talked about it. And for official or legal samples, container must be tamper proof and it must be sealed properly. So the official samples must be sealed properly, and they must be in duplicate. They must be chain of custody identified clearly, and the sample must be collected in duplicate, so that one control sample is there at the agency which is asking you to carry out the sample for official and legal point of view. Now let us see a layout of an agriculture product. What kind of things you should cover? You should cover short but appropriate index identification, title of sampling. Introduction, describe the purpose of the plan. Scope, for which this is what this plan covers, what? Describing the breadth of coverage. Field of application, products to be covered, where sampling will be done. Reference, documents the validity of the plan with reference to other requirements. Definitions we must mention, specify terms associated with particular metrics, because if the definition of terms used is not there, properly understood by the person, the stakeholders involved, it may lead to problems. Principle, a statistical basis of method of sampling, it must be specified. This is the layout for a standard method of sampling for any lot. This is as per the standard, the given standard. Administrative arrangements has to be taken care of. The person who is going to go for sampling must be authorized. Representation of parties concerned, there must be an agreement between the one who is carrying out the sample and the sampling, and the person whose lot has to be sampled. Health, safety and security precautions. Preparation of the sampling report. Identification and inspection of the lot prior to sampling. Sampling equipment and ambient condition. Sample containers. Sampling procedure. Sampling size. Taking the sample. Preparation of bulk samples. Selection of samples. Pre-packaged products. All that has to be the part of the layout. Packing, sealing and marking of samples in same containers. For example, filling and sealing sample containers, labeling it properly, packing sample for storage or transportation, precautions during storage and transportation of sample, sampling report, then administrative details of unit packs or enclosure containing the lot, material samples, marking and sealing of the samples, and all the annexures necessary for this. So all that we have to really make sure when we are going for a sampling. That was a layout. Now let's see the guideline for sampling of microbiology. This is very important. The microbes or group of microbes of concern or of interest. So first, number of samples to be tested. We must decide how many samples we are going to test. Testing method, which method we will use. Microbiological units, M, small m and large m. Now the small m, less than small m means acceptable. What is the population, what is the concentration of microbes, what is the microbial load, if it is less than m, acceptable. Then there is marginally acceptable. That means more than m but less than capital M. Capital M is dangerous. As I have already told you, if it is a very hazardous, if the attribute is creating hazards which can be fatal, like if certain microbes, if their presence is not allowed at all, can be fatal, that is what is representing capital M. So if it is more than small m but less than capital M, it is marginally acceptable. But if any sample is having a colony microbial load which is more than capital M, then the whole lot is rejected. So number of samples which fall into each category of microbial limit, acceptable, marginal and unacceptable, is the guideline that we follow. Standard for sampling, we have IS standard 2500-2000, and that is nothing but adopted from ISO 2859. I think all of you we must really refer to it. We must really remember AQL and LQ concept there. This is about coning and quartering. I was just mentioning to you that how from a large heap you take out and draw the sample. With these words, I say thank you very much for the time that you have given for this part of sampling. Jai Ram Ji ki.